Hello, dear students. Welcome to UGC Pathshala program. I am Professor Sandhya from School of Economics, University of Hyderabad, Hyderabad. Today you are going to learn on a module called Population Projections by Technical Group, Registrar General Office for India and large states. The learning objective is what is the need for population projections and projection methods by technical group appointed by Registrar General of India. Then there are assumptions regarding fertility, mortality and migration. Then population projections for all India as well as large states are going to be dealt in this module. Let's start with the definition of population projection. Population projection means estimating or forecasting or predicting the population for future dates based on the past experience or trend of a country or an area for a given time. National Population Policy 2000 has stated that Government of India is committed to stabilize population of India by 2045. In that context, it is important to have an idea of the likely growth of population in future for taking corrective steps at present to achieve the above said goal. So, let's look at some other need for population projections. All development plans, either social, economic or regional, depend on the future population, its size and characteristics and distribution. The future requirement of a country depends not only on the size of the population, it also depends on its sex-age distribution, its distribution by occupation and climate, etc. For social planning also, calculating for dependency of the old age persons in a population, we need the data on age and sex for the pension planning and social security measures. For estimating the schooling needs of an area, we need the distribution of children by age, sex and even by residence status. So, various development schemes targeting to improve the quality of life require information on the number of persons in future in different age groups, their rural-urban distribution, etc. So, thus the need for the projected population is not only being felt by the official agencies alone, even private sector need age sex-wise projected population for better planning for their businesses. Population census was conducted in India once in 10 years only. The periodic census enumeration gives data on the size and composition of the population at the time census was taken. But for many purposes, it is important to know the number and characteristics of the people at different dates between the two census periods. For this, quinquennial projections are required. Population projections are made under certain realistic assumptions made on the trends, based on the trends of the past data. The assumptions made with their probability of coming out to be right forms a critical input in this mathematical effort. India is the second most populous country in the world. The size and growth of India's population have remained a matter of great interest not only to India but also to the outside world also. Different population projections at the country level are made by the government, national and international agencies from time to time. Individual demographers make their own projections for the country as a whole and sometimes at subnational levels also. The international agencies which make the projections for the world and for the individual countries are UNDP, the World Bank and UNFPA. What are the previous projections that were done in India? In India, Office of the Registrar General and Census Commissioner undertook the exercise of population projection on behalf of the Planning Commission of India for the first time in 1958. The first expert committee on population projections was set up by the Planning Commission in 1958 to provide a set of population projections for India and states to use in the preparation of the third 5-year plan. Thereafter, this committee was revived from time to time to revise official projection figures on the basis of the latest available census data. The present technical group was formed for technical group on population projections for the period 2001 to 2025 was set up by the Planning Commission to undertake population projections for all India and major states. Population projections for India. Here, the component method was used for making population projections. The growth of population is determined by fertility, mortality and migration rates. This method incorporates the assumptions with regard to the above three components. In this exercise, the component method was applied for 21 states of India. These are Andhra Pradesh, Assam, Bihar, Gujarat, Haryana, Himachal Pradesh, Karnataka, Kerala, Madhya Pradesh, Maharashtra, Orissa, Punjab, Rajasthan, Tamil Nadu, Uttar Pradesh, West Bengal, Jharkhand, Chhattisgarh, Uttaranchal, Jammu and Kashmir and Delhi. In addition, projection of 7 northeastern states, excluding Assam, as a whole has also been carried out using the component method. For the remaining states and union territories, mathematical method has been applied. The sources of data used are 2001 Census and Sample Registration System. SRS provides time series data of fertility and mortality, which has been used for predicting their future levels. We need base level population data for making the projections. We require the following base level data for the projections. One is age-sex structure of 2001 census. The age structure data of 2001 was used as the base level data. Age data is subject to errors to some degree. In many cases, the erroneous reporting of age is attributable to ignorance of respondents. So, there is a need to smoothen the age-sex distribution. Age smoothing method is the committee has selected strong method of smoothing, gave the lowest values of sex and age ratio scores as shown in table. So, the technical group recommended this method for age smoothing. Strong method is described as follows. If W1, W2 up to Wn are the respectively the n quinquennial age groups of 0 to 4, 5 to 9, 10 to 14 and so on and so forth, then SW2 equal to 0.25 into OW1 plus 0.50 into OW2 plus 0.25 OW3, where S is the smoothed population and O is the observed population. In this way, smoothing of all the n-2 except the first group of W1 and last group of W1 age groups was done. For smoothing, W1 has been smoothed as follows. S W04 equal to S O W04 014 minus S W59 plus S multiplied with W104. Similarly, for SW75 also is done. The age and sex ratio score based on the above smoothing procedure are given in table 1, showing the accuracy index of as 15.60. Smoothing of age-sex distribution for India and all major states including Himachal Pradesh, Delhi and northeastern region have been carried out by using the method. The smoothed population of 2001 by age and sex for India and the states for which component method has been applied is presented in table 2. So, now we will start with the assumptions regarding fertility. SRS and NFHS provide estimates of TFR for the states of the country. SRS data were used as base level estimates since they are available in a time series. The SRS data shows that in most of the states, total fertility has been falling since 1971. Although annual estimates of TFR are available from SRS since 1971 till 2002 for India and major states, reliable estimates are available from 1981 onwards. So, the trend analysis of TFR can be done using log linear, logistic and Gomford's models for projecting the future levels of fertility. Gomford's model may be used for projecting the future levels of TFR in all the states as well as for the country as a whole. Following are the mathematical forms of the three models. Gomford's model, the equation is TFR minus L divided by U minus L equal to A raised to the power B or B raised to the power T, or alternatively you can take the logarithms method, natural logarithms for that and obtain the values for A and B, where U and L are the upper and lower limits of TFR respectively and T is the time, A and B are the constants. The lowest level of TFR was assumed to be 1.8 for all states except Himachal Pradesh. The observed values of TFR for 1981 to 2000 from SRS were used for projecting the future levels of TFRs. TFRs are available from 1981 onwards. For Himachal Pradesh, TFR for 1991 to 2000 were used as they were not available for the earlier years. In fitting the Gomford's model, three types of upper asymptotes have been taken for the states depending upon whether the particular state is higher or medium or low TFR state. The upper asymptote U has been taken as 6 for southern states and 7 for the northern states and 6.5 for western and eastern states. Table 3 gives the projected value of TFR for India. It gives the unweighted estimates of TFR along with the weighted average of TFRs for the quinquennial period 2001 to 2025 at 5-yearly intervals. Table 3 gives the projected level of TFR for all India for the above quinquennial period. There are two estimates, unweighted estimates and weighted estimates. The weighted estimates of TFR were recommended for the population projections for India. The weighted estimates of TFRs for India for these years are based on the TFRs of 21 states. The weights are percentage share of countries' females in the age group of 15 to 49 for different quinquennial periods starting from 2001. Table 3 gives projected levels of TFR India for 2001 to 25. The TFR obtained through the Gaufford's function, especially that replacement level TFR of 2.1 for the country as a whole is likely to be achieved by 2015 when unweighted TFRs are taken into consideration. When weighted TFRs are taken into consideration, the replacement level is likely to be achieved by 2021. By 2010, the TFR is expected to reach 2.6. The probable year by which the replacement level TFR of 2.1 will be achieved by different states and India under the assumption that the recent pace of decline in TFRs observed during 1981 to 2000 continues in the future years also is shown in Table 4. Table 4 shows that South Indian states achieved replacement level of TFR at an earlier year compared to others. Now let us look at the sex ratio at birth. It is defined as number of male births to 100 female births. Sex ratio at birth for 1998 to 2000 were obtained from the report of the Sample Registration System 2000 published by the Office of the Registrar General, India for the country and the major states. These have been used for the present projection exercise. Sex ratio at birth for states of Jammu and Kashmir, Chhattisgarh, Delhi, Jharkhand and Uttaranchal are not available in the said report. Those for 0 to 6 population based on census 2001 have been used for the exercise. In case of combined northeastern states, sex ratio at birth has been considered based on the observation of the individual northeastern states. The sex ratio at births of all the states are assumed to remain constant during the future years. Sex ratio at births are considered for the projection is given in Table 5. Now let us come to the assumptions regarding mortality. For projecting the likely levels of expectation of life at birth, working models developed by the UN have been used. UN uses a standard pattern of improvement in expectation of life at birth depending on whether the expectation is likely to imply slowly, moderately and fast based on the historical patterns. It has been assumed that the increase in the life expectancy becomes relatively slower as it reaches higher levels. The age-specific survival rates were calculated by assuming that the age pattern of mortality observed in SRS for 1999 to 2001 would slowly converge to West model of life tables pattern as levels of life expectancy increases. The average SRS-based age-specific death rates for 1999 to 2001 centered at 2000 was taken as base year. Separate life tables for males and females separately for each state have been constructed without taking into consideration the omission factor due to death reporting. 3 years average was chosen since the year-wise mortality rates, particularly at the state level, would be subjected to high variability. The West model life tables were adopted as the standard life tables in this purpose. To decide whether high, medium or low improvement should be assumed for each state, the expectation of life at birth for the periods 1990, 94 and 95, 99 obtained from SRS life tables have been examined and the pattern obtained through this for E0 has been assumed to continue in the future for India and all the states. With the help of the West model life table and the expectation of life at birth base level, the value of NLX for each 5-year age groups were projected up to 2021-25 by interpolation method. The West model life tables were adopted as a standard life tables for this purpose. Table 6 gives the summary of base year population data with regard to fertility and mortality for India and all other states under the assumptions for from 2001 to 2025. Assumptions regarding migration. Based on the migration data from Census of India 2001, interstate net migrants during decade 1991 to 2001 has been assumed to remain constant throughout the projection periods for all the states except Goa. The component of international migration has been assumed to be negligible, so it has not been considered for the projection exercise. Summary of base level data used in the projections is given in Table 6. Table 7 gives the projected values of net migration for the projected period of 2001 to 5 to 2021 to 25. Projections for newly created states. Separate projections for the three truncated states of Uttar Pradesh, Bihar and Madhya Pradesh and the respective newly created states of Uttaranchal, Jharkhand and Chhattisgarh have been worked out. Basic demographic information of fertility and mortality of the three truncated states of Uttar Pradesh, Bihar and Madhya Pradesh are available from the sample registration scheme data from 1999. Projected TFRs of the newly created states and the truncated states were worked out by using the population of 0 to 6 years from the census 2001. It is known that there is a strong positive relationship between the growth rate and the child population in the age group of 0 to 6. The ratio of child population to the total population of each of the above mentioned 6 states was available from census 2001 have been used for separating the TFRs of the undivided states into each of the 2 states. For example, the TFR of undivided UP has been separated into TFRs of newly created UP and Uttaranchal by using the proportions of 0 to 6 population based on census 2001 of these 2 states and also the similar proportion of a state for Himachal Pradesh. The assumed expectations of life at birth by sex of a newly created state for the future years have been worked out by using the age-specific death rates of the undivided states and adjustment factor based on NFHS 2 data of the newly created state. The component method was used for projecting the population of major states only, which have population of 10 million and above. An attempt has been made for the first time for working out the population projections of Jammu and Kashmir, Himachal Pradesh, Delhi and northern states combined excluding Assam by component method. The states included in the northeastern states are Arunachal Pradesh, Manipur, Meghalaya, Mizoram, Nagaland, Sikkim and Tripura. Projections of Delhi were made by the mathematical method earlier as it was not a major state. As per 1991 census, in 2001 component method was used for projections because during 2001 census its population has exceeded 10 million and also in Delhi migration is a major component of population growth. So, component method is appropriate for this. Fertility data for Delhi was available from 1995 onwards up to 2000 which was being used for projecting the future levels of fertility. Mortality, the age-specific death rates for the years 1999 to 2001 were used for working out the expectation of life at birth for the base year for Delhi. Projections for northeastern states combined TFRs for early years based on available data from 1995 onwards till 2000 has been used to project the future levels. In case of mortality, the age-specific death rates for the year 1999 to 2001 has been used for working out the expectation of life at birth for the base year. Based on the projected population of the combined northeastern region for the quinquennial periods 2001 to 25, the projected population of each of the 7 states of the region excluding Assam for the quinquennial periods 2001 to 2025 have been worked out by pro rata distribution of the population based on 2000 census population. Pro rata, what is the pro rata method? Proportion of population of each of the 7 states to the total population of these 7 states based on census 2001 have been worked out. Then assuming the proportion to be constant in future years also, using the same proportion to the total projected population of the northeastern region. For each of the quinquennial periods, the projected population of each of the 7 northeastern states for the quinquennial periods 2001 to 25 have been worked out. The projected population of India and its characteristics are given in Table 8. Table 9 gives various demographic indicators of projected population of India. Projected population figures of all major states for quinquennial periods 2001 to 25 were given in the technical report. Table 9 gives the basic demographic indicators of India from 2001 to 2025. The basic indicators are population growth rate, which is ranging from 1.6 at 2001 to 5, and it is supposed to be reaching 0.9 by 2021 and 25. Then crude birth rate, which is at 23.2 in the beginning of the projection period, is assumed to be reaching 16 by 2021-25. Then comes the crude death rate, which is in the beginning of the projection period, that is 2001 to 05, is 7.5, and it gradually decreases to 7.2 in 2021-25. The next demographic indicator is infant mortality rate, that is at the base of the year 2001 to 5, it is 61.3, and it gradually decreases to 40.2 by the end of the projection period, that is 2021-25. Then comes the under 5 mortality rate, which is at 82 in 2001 to 05, and it is also reduces to 54 at the end of the projection period, that is 2021-25. The next indicator is total fertility rate, which is at 2.9 in 2001 to 5 for all India. It is gradually decreases to 2 at 2021-25, which is required for, which is little lower than the above replacement level of achieving replacement level of NRR equal to 1. For NRR equal to 1, the TFR should be 2.1. Life expectancy of males is at the base period 2001 to 5, it is 63.8, and it gradually increases to 69.8 by the end of the projection period, that is 2021-25. Whereas life expectancy of females, which is at the beginning of the projection period 2001 to 5, is 66.1, which is increasing to 72.3 by the end of the projection period, that is 2021-25. So here you can notice the expectation of life at birth, life for females is higher than the males. The projected population figures of all major states for quinquennial periods starting from 2001 to 2025 were given in the technical report in appendix tables. Now let us conclude the module by saying that in this module, component method of population projections was used. The base level data is being obtained mostly from 2001 census data and also SRS reports, and applying realistic assumptions on fertility, mortality and migration. Population projections were made by the technical group for all the major states through component method for quinquennial periods of 2001 to 25. These projections will be used for all the social and economic planning as well as pension planning, and also school enrollment planning, and also the number of schools and hospitals to be planned for the population of the future periods. Thank you.